Okay, so in this video, I'm going to teach you what medians and centroids of a triangle are, and then how to use them to solve problems using medians and centroids. So I have a triangle here. It's drawn with all three of its medians. So a median of a triangle is just a line that connects the vertex to the midpoint of the opposite side. Vertex to the midpoint. Vertex to the midpoint. So these are all the midpoints of the sides of the triangle. So that should make you think, or just pause for a little bit, because we've been doing a lot with midpoints. So that's obviously going to come into play. Okay, now where the three medians intersect, this point right here is called the centroid. Okay, so you could write that down. The centroid is the point where all three of the medians of a triangle intersect. Now the cool thing about the centroid is that it is the point of balance for any triangle. So like if I wanted to, I can't even think of an example here, but if I like had a piece of string and I attached it to this point of the triangle right here, and I hold up the string and I pulled up the triangle would hold, or would hang perfectly flat. Sorry, I'm putting my hand like right in your face there. Because that's the point of balance. So if you ever need to know the point of balance for a triangle, just construct the medians. Boom, where they intersect is the centroid. Okay. Now the centroid cuts the median into thirds. So like for example, this median right here, and this centroid, this portion here is a third of the whole median. This portion here is 2/3 of the whole median. So if my median was, let's say, 9 inches long, that would make this portion 3 inches, and this portion would be 6 inches. Okay, so we'll do some problems using the centroid as well. So let's do our examples. So the first one here, it says find x if QP is 7x plus 3 and TP is 3x plus 3. Okay? Now this triangle has been drawn with its median. This line right here is the median, which means that T is the midpoint of this side of the triangle. So in this problem, there is literally nothing new that we're doing other than the fact that it's a triangle and a median. But we've been working with midpoints of segments and setting up problems using midpoints of segments for a long time now. Okay? What we've been given is a half and a whole. So I'm going to take my half and I'm going to double it and set it equal to the whole. Okay? There it is. There's my equation. Should look pretty familiar. You solve that equation, you get x equals 3. Okay? So again, that same question we've been asking ourselves, do I have a half and a whole? Do I have two halves? You're asking that same question. Okay? Your answer to that question determines how your equation is set up. Let's do another example. There we go, second one. Alright, so now you've been given VJ, 2x plus 2, and VK is 3x. Again, a triangle with one of its medians means that V right there is the middle. So, what have I been given? 2 halves or a half and a whole? Well, I've been given 2 halves, so you just set them equal and solve. 2x plus 2 equals 3x. You just wind up with x equals 2. Okay, pretty simple equation to solve. Let's do the next one. It looks a little scary with fractions. You should perhaps go ahead and pause the video, see if you can set it up and figure out x on your own. We've been given RV and RU. Okay, so in this case I've been given 2 halves, so 1/2 x equals x minus 7 over 2. Don't let the fractions scare you. Your buttons in your calculator are just alpha and then y equals if you have the TI-84. That will allow you to put a fraction in. When you solve here, you should get x equals 7. Okay, again, not taking as much time to go through the algebra because this is geometry. Am I right? Okay, example 3 on this page. Now we've got a triangle. All three of the medians are drawn in. That means this is my centroid. Keep that in mind. So I gave you KX. That's this entire line. This median is 3. okay? I want you to find the length of KZ. What does that equal? Well, remember, Z is a centroid. That means it's cutting up the median into 1/3 and 2/3. So if you're like, well, how do I know which portion is 2/3 and which is 1/3? Well, just use your eyeballs, right? This is shorter, that's longer, so that's the 2/3 portion. So all I do is just 3 times 2/3. And some of you can probably do that in your head, like 2/3 of 3 is just gonna be 2. Right, so your answer here is 2. Let's do our last 2 examples. Okay, in this problem, XA is what I've been given. So this guy right here, this is 4. I want AS. This is what I'm searching for. Okay? I still can't find what I'm searching for. So, this is my centroid. This is my 2/3. This is my 1/3 portion. Now, in this problem, we aren't given the entire thing. We're given the 2/3 portion. So, in this case, you really want to think about how are 1/3 and 2/3 related, right? Like how, if I've been given the 2/3, how do I get it to be 1/3? Well, you should think, okay, well 2/3 is just 2/3, right? So 2 of these equals 1 of these. So if I take this 4 and cut it in half and get 2, that's going to be my answer here, okay? Because 2/3 is double the length of 1/3. All right, last example. So JR is 10.3. It's going right there. Find XJ. This is what we're looking for. Bang, bang. J is my centroid. That means this is 1/3. This is 2/3 of the whole thing. I didn't give you the whole thing. You got the 1/3. So again, this is kind of like this last example where you're thinking, how do I get from here to here? Well, I'm just going to double it. 20.6, final answer. Read it and weep. Don't actually weep. Okay, these problems correspond to page 27 and 28 in your TAM packet. Try them out. Watch the fractions. Thanks for watching.